In this video, we're going to focus on uniform distribution probability problems. And so we have an example problem to start right here. Number 1, the amount of time a person must wait for a train to arrive in a certain town is uniformly distributed between 0 and 40 minutes. Part A, determine the probability density function f of x. So if you know what to do and you want to try it, feel free to go ahead, pause the video, and work on this example. Now, what you need to understand is that if you have a continuous probability distribution, the area under the curve, that is the total area, must equal to 1. And also, if this distribution, if it's uniformly distributed, that means that f of x is constant. It has a constant value over any equivalent interval of values between 0 and 40 in the case of this example. But now, how do we determine f of x? Well, let's draw a graph. Now, f of x is going to be constant, as we said before, because it's uniformly distributed. So this is going to have a horizontal line. And this is going to be from the interval a to b. So this is our f of x value, or our y value in this graph. And we said that the area under the curve, that is the area of this shaded region, which is basically the area of a rectangle, that's equal to 1. Now, what is the area of a rectangle? From geometry, you know that the area of a rectangle is equal to the base times the height. So this is the base. Let's use capital B to distinguish it from a lowercase b. So the base is basically, as you can see, it's b minus a. Now what about the height? What's the height? The height of the rectangle is right here. Notice that it's equivalent to f of x. So let's replace h with f of x. And the area for any continuous probability distribution problem is 1. So now let's solve for this variable f of x. To do so, we need to divide both sides by b minus a. And so the probability density function, f of x, is simply 1 over b minus a. So that's the formula that we're going to use to get the answer for part A. Now, in order to finish part A, we need to determine what the values for A and B are in this example. So we were told that the time that the person must wait for the train to arrive in a certain town is going to be between 0 and 40 minutes. So A is the minimum value. A is 0. B is the maximum value, which is 40. So now we can calculate f of x. It's going to be 1 over 40 minus 0, or simply 1 over 40. So as we said before, for a uniform distribution, f of x is constant. It's simply equal to a number with no variables attached. Now, what about part B? How can we draw a graph of f of x? I'm going to put this graph on the right side. So here's the y value. This is going to be 1 over 40, and it's constant, so we're going to draw a horizontal line. A is 0, B is 40. And so that is our graph for f of x. It's going to look like a rectangle. That's all you need to do for part B. Now, sometimes you may get asked to write the constraint values for x. If you ever get a question like that, just know that x is always between a and b. So in this example, x is between 0 and 40. But now let's move on to part C. What is the probability that a person must wait less than 8 minutes? What do you think the answer is to that problem? So what is the probability that x is less than 8? Now what you want to do is represent this on a graph. So 8, let's say it's somewhere over there. We need to find the area to the left of this line. So here is the shaded region. What is the area of that rectangle? So the base, as we can see, is 8. The height is not going to change. That's 1 over 40. So area is base times height. Let's use capital B. So B is 8. H is 1 over 40. So this gives us 8 over 40. Now 8 over 40, what is that? Well, we know that 40 divided by 8 is 5. So 8 over 40 has to be 1 over 5. Now 1 over 5, 1 divided by 5 is 0.2 or 0.20 as a decimal. And 0.20 is 20%. So what this means is that there's a 20% chance that the person must wait for 8 or less minutes for the train to arrive. Now let's move on to part D. What is the probability that a person must wait more than 30 minutes? So based on the previous example, go ahead and try this one. So let's say 30 is right here. So we need to calculate the area to the right of 30, or between 30 and 40. So notice that the base of that rectangle is 40 minus 30, which is 10. And the height is still 1 over 40. So the probability that x is greater than 30, or you could say the probability that x is between 30 and 40, because these two will have the same answer, is going to be equal to the area of that rectangle. So it's base times height. Base is 10, height is 1 over 40. So this becomes 10 over 40. If you cancel a 0, that's 1 over 4. 1 divided by 4 as a decimal is 0.25. If you multiply that by 100, you get 25%. So there's a 25% chance that the person must wait more than 30 minutes for the train to arrive. Now let's move on to part E. So calculate the probability that x is between 10 and 26, or the probability that a person must wait between 10 and 26 minutes for the train to arrive. So what we're going to do is we're going to create a new graph, since that one has been used so extensively. So here's our rectangle from 0 to 40. F of x is still the same. Now we want to calculate the area between 10 and 26. So what is the area of that rectangle? So once again, area is equal to the base times the height. And as we can see, the base is between 10 and 26. So it's 26 minus 10. And the height is still 1 over 40. Now, 26 minus 10, that's going to be 16. And 16 times 1 over 40 is simply 16 over 40. Now, we could simplify that fraction. 16 is 8 times 2. 40 is 8 times 5. 8 divided by 8 is 1. And so the area is 2 over 5. Now, 2 divided by 5 as a decimal, if you type that into your calculator, that's going to be 0.40. So the probability that x is between 10 and 26 is going to be 0.40 or 40%. Now, what about the next one? What is the probability that x is equal to 20? I'm going to give you a minute to work on that one. Go ahead and try it. What do you think the answer is? Now, if you're not sure, sometimes it's best to draw a graph. So here's 40, here's 0. Now, notice that we don't have a range of values. We simply have one x value. So therefore, we have a line at x equals 20. Notice that there is no rectangle for line. Therefore, the area is going to be 0. If you try to use the formula, base times height, the base is 0. The base is usually the difference between two values, but you only have one value. So there's no way you can calculate the area for that. It's going to be 0. Now, what about the next one, where x is greater than 45? By the way, going back to this problem, anytime you see a problem where x is equal to a number, let's say if x is equal to 35 or 15, it's always going to be 0. Unless you have an interval values or two different x values, like this one. If you don't have it, it's going to be 0. Now, the probability that x is greater than 45. If we were to extend this graph, 45 would be somewhere here. But notice that f of x is 0 beyond 40. So if you were to try to use the formula, base times height, your base could extend to infinity, but your height is 0. So basically, you have no rectangle. So if your height is 0, the area is going to be 0. Therefore, the probability that x is greater than 45, because it's outside of the range of 0 to 40, the probability is going to be 0. So that's the answer for that one. Now, let's move on to part F. Calculate the mean and the standard deviation. So for a uniform distribution, the mean is going to be a plus b divided by 2. It's basically the average of the minimum and the maximum. The mean and the median for a uniform distribution is the same because it's symmetric on the left side and the right side of the mean. A is 0, b, the maximum value, is 40. So the average of 0 and 40 is going to be 20. So that is the mean for this problem. Now let's calculate the standard deviation. Here's the formula for the standard deviation. It's going to be b minus a divided by the square root of 12. So that's going to be 40 minus 0 divided by the square root of 12. 40 divided by the square root of 12 is 11.547. So you can round that to 11.5 if you want to. So that's how you can calculate the standard deviation for this problem. Now, what is the 85th percentile? Feel free to pause the video and try it if you want to. So let's go back to our graph. Now let's break this up into 4 equal parts. The mean is 20. The minimum 0 is basically the 0 percentile. The mean is at the 50th percentile. And 40, which is the maximum, that's at the 100th percentile. 10 is at the 25th percentile. And 30 is at the 75th percentile. So the 85th percentile is somewhere between 30 and 40. Let's call that value k. So k is the value that we're looking for that corresponds to the 85th percentile. How can we find k in this problem? First, you need to understand that the 85th percentile corresponds to the area to the left. I said that wrong. To the left, rather, of the k line. So the area of this rectangle that we shaded is 85% or 0.85. So the area on the left side is going to be equal to the base times the height. And the area is the same as the probability for any continuous probability distribution function. So we can replace the area with 0.85. Now the base of the rectangle is the difference between k and 0. So it's k minus 0. The height is still the same. That's 1 over 40. So we have 0.85 is equal to k minus 0 is simply k, and then times 1 over 40. To get rid of the fraction, we can multiply both sides by 40. So the 40s will cancel on the right side. And thus k is simply 40 times 0.85. So because this particular problem was centered at 0, or it started at 0, the 85th percentile is simply 85% of 40. 40 times 0.85 is 34. Now, is this answer reasonable? Does it make sense? 34 is between 30 and 40, so that's a reasonable answer. So that's how you can calculate the value of a percentile given a uniform distribution problem. Now, for the sake of practice, let's try another example. You could work on it if you want to. Go ahead and pause the video and give it a shot. Number 2, the amount of time that it takes a student to complete a chemistry test is uniformly distributed between 20 and 45 minutes. Part A. Write the probability density function f of x. So the probability density function, or the PDF, is going to be 1 over b minus a. So now, what are the values of a and b in this example? Well, we could see that x is between 20 and 45. So therefore, a is 20 in this example, and b is 45. So this becomes 1 over 45 minus 20. 45 minus 20 is 25. And so f of x is equal to this. Now let's move on to part B. Draw a graph. Now a is 20 and b is 45. And let's say this is f of x, which is 1 over 25. All we need to do is draw a rectangle between 20 and 45. So that's it for part B. Now for part C, what is the probability that a student will take more than 36 minutes to complete the exam? So what is the probability that x is greater than 36? So let's say 36 is right here. What we need to do is calculate the area of this shaded region. So we know the area is going to be the base times the height. So this is the base. That's the difference between 45 and 36. And then the height of the triangle is going to be f of x, which is 1 over 25. Now, 45 minus 36 is 9. So this becomes 9 over 25. 9 divided by 25 is 0.36 as a decimal, which is 36% if you multiply it by 100. So that's the probability that x is greater than 36. So that's it for part C. Now, let's move on to the next part, part D. What is the probability that the student will take between 26 and 35 minutes to complete the test? So go ahead and try that. So let's say 26 is here. And let's say this is 35. So I'm going to highlight the area in red to distinguish it from the last one. So this right here is the new base. So the area of the triangle, not the triangle, but the area of the rectangle shaded in red is going to be the base times the height. So the base is 35 minus 26, and the height is still the same. Now 35 minus 26 is still 9. So the answer is going to be the same as last time. That is, it's going to be 0.36. So the probability that x is between 26 and 35 is once again 36%. Now let's move on to part E. So first let's clear away some stuff. Let's start with the median. Now, because we're dealing with a uniform distribution, the mean and the median are the same. So we could use this formula, a plus b divided by 2. So that's going to be 20 plus 45 divided by 2. So that's 65 divided by 2. 65 is basically 64 plus 1. So we can write it like this. Half of 64. 6 divided by 2 is 3. 4 divided by 2 is 2. So 64 divided by 2 is 32, plus a half. So it's going to be 32.5. So that is the mean. Now let's calculate the next thing, the variance. So the variance is going to be b minus a squared divided by 12. B is 45, a is 20. So 45 minus 20 is 25. 25 squared is 625. And 625 divided by 12 is 52.083. So that's the variance. Now the standard deviation is simply the square root of the variance. So it's going to be the square root of 52.083. And so the standard deviation is 7.217. So that's it for part E. Now, let's move on to part F. What is the value of the third quartile? To get the answer for this one, it's going to be helpful to draw a graph. So this is A, this is B. And the y value is 1 over 25. Now we're going to break this interval into 4 subintervals. We said the median was 32.5. The median is the second quartile. This is the first quartile. And this is the third quartile. The first quartile is the 25th percentile. The second quartile is the 50th percentile. And the third quartile is the 75th percentile. So what we need to do is determine the value that corresponds to the 75th percentile, which is the third quartile. And we're going to call it K. So the area of the rectangle to the left of K is 0.75 because it corresponds to the 75th percentile. So the area of that rectangle on the left is going to be the base times the height. So the area is 0.75. The base, the length of the base of the rectangle, is the difference between K and 20. So we're going to say K minus 20. And as we know, the height is f of x, the probability density function, which is 1 over 25. So now we need to do some algebra. Let's begin by getting rid of this fraction by multiplying both sides by 25. So these will cancel. So 25 times 0.75 is 18.75. And so we're left with this on the right side, which is K minus 20. The last step is to add 20 to both sides. So 20 plus 18.75, that's going to be 38.75. And so this right here is the 75th percentile. And as we can see, the answer makes sense because it's in between 32.5 and 45. Just as 75 is between 50 and 100, if we were to average these two numbers, it would give us the answer. 32.5 plus 45 is 77.5. If you divide that by 2, it will give you 38.75. Now, let's move on to the last part, part G. What is the probability that the student will take more than 40 minutes to complete the test, given that he always takes more than 30 minutes to complete any chemistry test? So we have the key word given. Go ahead and try this problem. So first, we need to recognize that we need to calculate a conditional probability. The formula for conditional probability, let's say if we want to find the probability that event A occurs, given that event B has already occurred, this is the probability of getting A and B. This is the intersection between A and B, divided by the probability of event B occurring. So in terms of this problem, we want to find the probability that x is greater than 40, given that x is already greater than 30. So it turns out that this is equal to the probability that x is greater than 40 divided by the probability that x is greater than 30. And let's talk about why that's the case. Now, looking at the first formula, we can illustrate this with a Venn diagram. Let's say A is on the left, B is on the right. So where the two circles overlap, that is the intersection of A and B. So the probability that A will occur, given that B has already occurred, is basically the area of this portion, that is the intersection of A and B, divided by the entire area of the circle that's represented by B. Now in this problem, we're going to do something similar. So let's begin with a picture. So let's say this is 20, this is 45, and here is our rectangle. In this case, B would be the area from 30 to 45. So 30 would be here. So I'm going to highlight B in red. Now A would represent the area that is between 40 and 45. So A would be this region. So notice that the region where A and B overlaps is between 40 and 45, because you have both A and B shaded in that region. And then the entire region of B would be from 30 to 45. So that's why this formula is going to work. So now the probability that x is greater than 40, that's going to be the area of the rectangle highlighted in blue. So the base of that rectangle is 45 minus 40 times the height, which is 1 over 25. Now, for this one, the probability where x is greater than 30, the base of that rectangle is from 30 to 45, and the height is the same. So we could cancel 1 over 25. 45 minus 40 is 5. 45 minus 30 is 15. So 5 over 15. 15 is basically 5 times 3. 5 is 5 times 1. We can cancel a 5 and get the answer 1 over 3. And 1 over 3 as a decimal is basically 0.3 repeating. So the probability that the student will take more than 40 minutes to complete the test, given that he always takes more than 30 minutes to complete any test, that answer, which I'm going to write here, is, let's multiply this by 100, so that's going to be 33.3%, with the 3 repeating. So that's it for this video. Now you know how to solve probability problems related to uniform distribution situations. Thanks again for watching.